In this problem, we're asked to multiply two algebraic fractions. As always, you need to factor first. You can't cancel terms. With a minus sign or a plus sign, we have terms. We only can cancel like factors. So this first numerator is the difference of two squares, n squared plus 4, n squared minus 4. This further factors into n plus 2 times n minus 2. The denominator n fourth minus 1 factors into n squared plus 1 and n squared minus 1. This second factor factors further as n plus 1 and n minus 1. Notice there's no way that we can factor the sum of two squares, only the difference of two squares. The second quantity, all I did is put the binomials in parentheses to emphasize factored as a unit. I don't want separate pieces, I want a unit, so I put the parentheses around each. Now I look for like factors, so this factor and this factor cancel, leaving a 1. This factor and this factor cancel, leaving a 1. And I'm left with the following factors: n plus 2 times n minus 2 over n plus 1 times n minus 1. In this problem, we're asked to divide one fraction by another. We want to first convert the division. So I have 5t squared minus 23t minus 10 over 5t plus 2. Changing the division to multiplication if I reciprocate the second quantity. So it's 1 over 25 minus t squared. The next thing I want to do is factor both numerators and denominator. This is a trinomial whose lead coefficient is greater than 1. I'm going to use the same technique I've showed you in a previous video. I write factors of 5 both in forward and reverse direction. I write factors of 10, 2 and 5, 5 and 2, 10 and 1, 1 and 10. And then I want to go through the list on the left with the list on the right, looking for the inside product and the outside product to get 23. Looks like the inside product here is 2, and the outside product is 25. And if I subtract those numbers, I do get 23. So I put 5 and 1 as the first factors in the binomials. I put 2 and 5 in the order shown as the second factors in the binomials. I now need to choose the sign to get a negative 23. How about this is a 2t and this is a 25t? So the bigger number takes on the sign negative 25t plus 2t would give me negative 23t. And lastly, a plus 2 times a minus 5 is minus 10. So I factor the numerator. Put this denominator in parentheses to emphasize factoring. On the second fraction, the denominator is the difference of two squares. So it's 5 minus t and 5 plus t. We have like factors here that cancel, leaving behind a 1. We have opposite factors here. And we discovered in a previous video that opposite factors cancel, leaving behind a negative 1. So the final answer is going to be minus 1 over 5 plus t. In this problem, we're asked to subtract two fractions. As we recall from chapter 2, to subtract fractions, we have to have like denominators. And we want to find the LCD. I think for this problem, if we look at 12a and 3a squared, the LCD is 12a squared. We then want to convert these fractions into new fractions whose denominator is 12a squared. Well, to make 12a squared, we need to multiply by a over a times the first fraction. That would be a times 4a is 4a squared. A times 3 is 3a, all over 12a squared. For the second fraction, we have 3a squared, but we want to make it 12a squared, so we need to multiply by 4 over 4, which is a 1 factor. So 4 times the numerator is 4a squared. 4 times -2 is -8. Denominator is 12a squared. The next step is to subtract the numerators, keep the same denominator. So the denominator is 12a squared. First numerator is 4a squared plus 3a. Subtract this. That means both of these signs need to be changed. So this positive becomes a -4a squared, and this negative becomes a +8. We need to combine like terms. The 4a squared terms cancel each other out. We're left with a 3a plus 8 all over 12a squared. Here is another problem where we're asked to subtract fractions, and they have different denominators, but this is a special case. If we observe this special case, it's going to help us out tremendously. Note that the denominators are opposite. If from the second denominator we extract a -1, we're left with a minus 6 in the parentheses. If we take this minus sign over here and combine it with this, effectively multiply the 2, we get a plus. So instead of subtracting two fractions, we're now adding two fractions, and we have exactly the same denominator. So we don't have to do any modification. All we have to do is write down the common denominator and add the numerators, a squared plus 3. That observation saved us a lot of work and possible errors.